4.6, numerical integration. Also, I like to call it just the trapezoidal rule. All right. So on a trapezoidal rule, this is how we do it if we're given an equation. If we have to approximate using the trap rule, it's b minus a over 2n. I'd like you to write that. All right, so it's b minus a over 2n. And then what we need to do is we have our coefficients, so it'd be just 1 times your far left, okay, your far left y value. And then plus 2 times your next one, plus 2 times your next one, plus 2 times your next one, all the way until you get to your last one, it's 1 times. And this is the reason why. When we have a trapezoid, we kind of start connecting them like this. All right? And so what happens is we have b minus a over 2n, okay? N is your number of your widths. Your partitions. So then this left one, this very left one, how many times is it used? How many times is this very left one used? Once. However, how many times is this one used when we do a trapezoid? It's twice. And then twice again. And then twice again. Until the very end, how many times is it used? It's used once. So that's why we have that as our formula. All right, so it's 1, 2, 1. All right. Let's practice. Here we go. That's what I'm talking about. All right. So we're going to use the trapezoidal rule to approximate the integral 0 to pi of sine x dx. All right. And I'm going to use 4 subintervals. All right. All right. So on this one, we need to do our b minus a over 2n. So my b minus a, what's my b minus a? Pi minus 0 over 2 times, how many partitions am I having? 4. And so I truly end up having pi over 8. All right. So I have pi over 8, and then I need to do f of 0. All right. And then plus 2 times f of what? If I have 4 partitions and I'm going 0 to pi. So I'd have b minus a over 4, right? So my partition is pi over 4. So every interval of pi over 4 we're happening. So now I do f of pi over 4 plus 2 times f of pi over 2. And then plus 2 times f of 3 pi over 4. Then what? Just plus f of pi. All right. And again, we end with a coefficient of 1 because it's only used 1 time. All right. And so now we need to evaluate. Thank goodness we know our unit circle, right, guys? Yeah. That's right. So we have pi over 8 chilling. And then what is f of 0? So what is sine of 0? 0. And then I have 2 times, what is pi over 4? So sine of pi over 4 is square root 2 over 2. And then I have 2 times, what is sine of pi over 2? 1. And then plus, what 2 times, what is sine of 3 pi over 4? And then plus, what is sine of pi? 0 again. All right. And so then I just simplify it up just a little bit. I don't know. I wouldn't do it too much. too much. Anyway. All right. So those 2's cancel. These 2's cancel. So then I'm left with how much? 2 plus square root 2 square root 2. And then times pi over 8. All right, I honestly wouldn't go much further than that. All right, pretty good? Yeah. All right. So now let's talk about how do we get closer? How do we get closer to the actual approximation? More rectangles. In not this case, it's not rectangles, more what? Trapezoids. More trapezoids. All right. All right, so let's go back to geometry. Let's go back to geometry. How did we find the area of a trapezoid? 1/2. not quite our base 1 plus base 2. 1/2 our height times base 1 plus base 2. Now, if you had me for geometry, I always told you to do your height times the average of your bases. All right? Because that's truly what makes sense on that problem. Now, what we do with trapezoidal is I kind of think of it kind of being backwards. Because, yes, technically on our trapezoids, it's kind of like the bases. When we do our little function, our bases are truly like these things, right? However, I like to think of those as the heights. And so I think of this more as a base. And so I kind of do like base times like height 1 plus height 2 over 2. That's the way that I will kind of go over it. Even though technically, yes, they are the bases, because it's kind of like shifted of what you normally think of it. That's the formula that we'll use. All right. So the height or the base in that case is usually the width. All right. So here we go. I'm going to do the integral 0 to 11, but now we're going to use trapezoidal rule. So what is the width here? That's kind of the base in what I think of it as. 2. So now I have 2 times, now I have 2 height values. My height values are 1 and 2. So now I have 1 plus 2 over 2 because it's the average of them. All right. And then let's do the next one. So now I have a width of what again? 2. And then I have 2 plus 3 over 2. And then what's my width again? 2. And then the average of my heights or my y values are 3 plus 2 over 2. And then what's this one now? 1. I don't really like working with ones, and you'll see why in a second. So now I have 1, and then I should have what? 2 plus 1 over 2. And then what's my last one? 4. And then times 1 plus 2 over 2. All right, so now we just have to simplify it up. And I kind of want you to see why I don't really care for that one thing there. Because do what?
They all cancel out except for that one.
Exactly. All right. So if I have 2 times 1 plus 2 over 2, that actually ends up being what? 3. And then plus 5. And then plus 5. Then plus what? 3 halves. And then plus 6. All right. So we need to do a little bit more math, and we end up with 3 plus 5 plus 5 plus 6. What do we think of that as? How much is it? 19. Okay, so what do we think of 19 as? 38 over 2, and then we add the 3 over 2, and we end up with 41 over 2. All right. All right, let's keep moving. So let's do it again. So now I have the integral from 0 to 7. All right. So what 2 things are not really necessary here? The 15 and the 19. All right. So don't be tricked. All right, don't be tricked. All right, so let's use the trapezoidal rule again. So what's my first width or my height or my base? I don't really care. 4. And then times what? Negative 1 plus negative 2 over 2. Then plus, what's my next width? 1. How rude. This one actually plays nice afterwards, though. Then I get negative 2 plus negative 4 over 2. And then what's my next width? 2. And then I have negative 4 plus negative 6 over 2. All right. And that's where I stop. Okay. All right. So what do I get for my first number? Negative 6. And then negative 3. I told you it played nice. And then negative 10. And so I end up with negative 19. Now, I can't technically prove this, but let's go about thinking of it. Where was this graph located? Below the x-axis. Okay, I can't technically prove it with this. However, more than likely it's going to all be what? Below the x-axis. All right, I can't prove it because what do we know it's at x equals 1? I don't know. All right, it could be just going up and down, but anyway. Here we go. So this is from 2014, I believe. All right, this is a free response question from 2014. And we're going to do this problem, okay? We're not going to do part D, but we'll do A, B, and C. All right? All right. I need a good reader. Who likes trains? Gunnar likes trains. Go for it.
Train A runs back and forth on the east-west section of railroad tracks. Train A's velocity measured in meters per minute is given by a differentiable function VAT, where time t is measured in minutes. Selected values for VAT are given on the table above.
All right. Part A.
Find the average acceleration of train A over the interval 2 to 8.
All right. What does it ask for? Average acceleration. What did they give us?
2 to 8 velocity.
They gave us velocity. All right. So how do we get average acceleration? It's just what? I don't take an antiderivative.
Opposite derivative.
I don't take a derivative. I don't have a function.
Make a function.
The slope.
All right, so average acceleration is what? Algebra slope of velocity. All right, so here we go. So now I need to do V sub A of 8 minus V sub A of 2 over 8 minus 2. Okay, average algebra slope. All right, because we're going down. We're going from velocity to acceleration. All right, so it's a slope. So what is V sub A of 8? Negative 120 minus 100 over 6. So I end up with negative 220 over 6. I personally would leave it like that. Yes, I know we can simplify a little bit more. I don't want to. Now, it doesn't ask for units. However, I want to do our units here. So what would be my units here?
Meters per minute.
Meters per minute squared. All right. Technically, it's meters per minute, TJ. All right. All right. We love English. That's why I think part B is so funny. Go ahead, Gunnar.
Do the data in the table support the conclusion
I guess technically it's right. I don't get it though.
No, it's
No,
not.
because Mr. Francis is like, oh, that means like God's right.
All right. All right. Keep going. Keep going.
I feel like you're already reading it.
Go ahead.
Do the data in the table support the conclusion that train A's velocity is negative 100 meters per minute at some time t with 5 to 8? Give a reason for your answer.
All right. What theorem does this scream? This screams a theorem.
It's the one where you try to find like the slope, like the
Hmm.
No.
So, we need to figure out if the velocity is negative 100 sometime between 5 and 8. So, this is intermediate value theorem. So, since V sub A of t is differentiable, it must be what? Must be continuous. And what do we know? V sub A of 5 is equal to 40. And V sub A of 8 is equal to negative 120. What do I need to show? My inequality. So I need to say negative 120 is less than negative 100, which is less than 40. And then what gang sign do I throw out? IVT. All right, that should be totally sufficient. All right, let's do part C now. Go ahead, Gunnar.
At time t equals 2, train A's position is 300 meters east of the origin station.
What did they just give us?
Position.
They gave us an initial condition. At time 2, I am 300 meters east. All right, that is an initial condition. All right, keep going.
the train is moving to the east. Write an expression involving the integral that gives the position of train A in meters from the origin station at time t equals 12.
All right, let's do it now. All right, so here we go. So now I need to find S sub A of 12, which is equal to what? Where do I start? What is my initial condition? 300. Plus what now?
Come on, Josh, your turn.
Plus the integral from 2 to,
T.
not t this time, 12, because I'm actually trying to find 12. And I'm taking the integral of my velocity sub t. All right? All right, keep going. Keep going.
Use a trapezoid sum with 3 subintervals indicated by the table to approximate the position of the train at time t equals 12.
All right, here we go. So my S sub A of 12 is approximately 300, because that's my initial condition. Now I'm doing this part, and I'm using which rule? Trapezoidal. All right. Now, what on this right here at this question part is not needed? My 0 thing. All right. So I don't need that on this one. You following me? All right. So what's my width? 3. And then times what? 100 plus 40 over 2. And then plus 3 times 40 plus negative 120 over 2. And then plus 4 times negative 120 plus negative 150 over 2. All right. Honestly, guys, they would actually accept that on the free response question. All right. If we just actually wrote it there, they would actually accept it. All right. But I'm going to keep going just because. All right. So let's do it. So we have 3 times what? 70. So that's what? 210. And then we have 3 times negative 40. So that's what? Negative 120. And then we have 4 times negative 135. So it's really... Okay, so I'm going to do 2 times negative 270. So I get negative 540. And so we end up with negative 450. Now, this is the way I would actually answer the question. Which way is this train moving?
East.
It's moving east. So I would say it's negative 450 meters. Is it meters or miles? What is it? Meters east. All right. Which technically means what? It's 450 meters west. However, I always kind of just give them what they gave me. All right. It's negative 450 east. All right. So I'd like you to finish tables 3 through 6 on your worksheet, as well as do 2011 through 2014, but make sure to do the Riemann sums of them. All right. 2015, 2013, and 2010. All right. All right. I want you to make sure you do at least the Riemann problems on it. Okay.